Hi, I'm Rusty Schmidt, landscape ecologist. In this tutorial, we'll demonstrate a phosphorus load reduction calculator, and it will also calculate the nitrogen and total suspended solids in the rain garden that you're creating. The next piece that we're going to talk about is the pollutant calculator. The pollutant calculator is a calculator to determine how much good a rain garden does. And so what we're going to figure out is how much pollution is actually being captured and treated within the rain garden. There's three factors that we're looking at: phosphorus, total nitrogen, and total suspended solids. The first page that shows up is this phosphorus. If you look at the bottom, there's 4 tabs. The next tab is nitrogen. The following tab is total suspended solids. And the final tab is the values. That's where you're going to actually start. So this is the numbers that we're going to put in for area that goes into our rain garden. Again, we've set up this Excel spreadsheet that only the areas in green or colored are going to be the areas that you're changing. And in this case, the last time I used this calculator, there's 5,600 square feet of street and 5,600 square feet of parking lot that was captured in this rain garden the last time I used it. So you can kind of see that it was set up for a more municipal project for a parking lot and street. But in this case, we're going to change it for your property, and we're going to use similar numbers that we used in the rain garden calculator. So if you remember, it was 3,385 square feet of lawn. We didn't have any streets, so we're going to change that to 0. Parking lot, let's say there's 1,000 square feet of driveway going into your rain garden. So it doesn't say driveway, but parking lot and driveway are pretty much the same thing. It's a place where you park where you get drips and drops. And then the last one is roof. And if you remember, there's 560 square feet of roof. So if you put that all together, you'll notice that it adds this up for you, and that you had 4,945 square feet of total area going into your rain garden, which is 0.11 acres. So there's 560 square feet in an acre, so it does that calculation for you as well. So it's 0.11 acres going into your rain garden, and it captured there's potentially 1.35 pounds of phosphorus that's on the property that could move, and that's gives you that number of what is actually available. Okay, so that gives you the first numbers. We're going to now go over to phosphorus, and we're going to figure out how much good this rain garden is going to do. Again, we've changed the colors. The areas in yellow or orange are areas that you're going to change. The areas in blue you never touch. Those are calculated for you in this Excel spreadsheet. And so this gives you the idea of how this calculator works. The first piece is, the first one in white, is the amount of rain that falls on the Twin Cities metro area. And we've figured this out over time. Just about 34 inches of rain falls on the Twin Cities metro area annually. And this is a 30-year average. It's gone up over the years, but this is where it is about now. And so don't mess with this. This is pretty good. Good number of expected rainfall event over the year. The runoff coefficient is that blue area. It calculates that for you, and this is the amount of water that potentially could run off from that 33 inches of rain. So that's 0.55. It tells you that's a coefficient or a percentage of the rain that's going to run off and potentially be stormwater. The next area is the yellow area. And this is the big one that you have to change every time. And the first piece to this is it explains what is a watershed impervious, the percent impervious that's on the property. To figure that out, you actually have to go back to this values tab. And what you're trying to do is figure out how much, or the percentage of area that is impervious. So the lawn is pervious, so we don't calculate that, but the parking lot and the roof is impervious. Add those two up, it's 1,560 square feet, and you need to divide that by the total area, or 4,945 square feet, and that comes out to 32%. So going back to the phosphorus calculator, you change this to 32. So that's the percent of impervious surface that's running off of the property. The next two numbers are numbers that you have to check just to make sure that this calculator is still working properly. The first one is amount of phosphorus pollutant that's being captured. The second number is the area in acres. And we kind of looked at that earlier. It's in that values calculator, 1.35 phosphorus, 0.11 acres of area going into the rain garden. Just make sure that those numbers are the same, 1.35, 0.11, so the calculator is working properly. So we go back to the phosphorus, and so it figures out how much phosphorus is being generated from towards your rain garden. Now that we have to figure out what kind of rain garden you have and how much will it stop. And there's different options here. We have infiltration rain gardens, which are the ones that we're showing. These are the ones without under drains. These are the standard rain gardens that we've been talking about. However, there are options, and it's a pull-down menu, of bioretention, filtration, or shoreline buffer. Same as down here. So if it's a rain garden, it's infiltration. If you look at infiltration, total phosphorus, it's 100%. This changes, you keep this at 100%. And by doing that, what happens is we're capturing the 0.35 pounds of phosphorus per year. It's right here. 0.35 pounds of phosphorus per year is being stopped in this rain garden from moving down the watershed. 0.35 pounds is pretty significant. Remember, 1 pound of phosphorus makes 500 pounds of algae. And so 0.35 pounds of phosphorus is actually 175 pounds of algae that we are not growing in the local lake, river, water body, whatever is downstream. So that's the amount of phosphorus we're stopping. If your rain garden is a little bit different, let's say you do have a bioretention that you have an under drain, and we've talked about it, but we haven't quite designed it. But let's say it's a bioretention. Bioretention for phosphorus is 65, so you need to change this to 65. And you'll notice that that changes the amount of phosphorus that you're stopping. Some of that phosphorus is staying in solution and running down the drain, which is why you're not capturing quite as much, which is why we keep talking about trying to build an infiltration basin only. Okay, so we're going to keep that as infiltration. Okay, now let's say you actually have more impervious surface. Let's say it's 56%. Instead, if it was 56%, you'll notice that the phosphorus load changes for you and it's gone up. So you're actually capturing closer to 0.6 pounds of phosphorus on property. So this is important to know that you need to make sure you have that impervious surface number accurate, and you calculated that out from the values page. Go back to 32 just because I want to show you that we now need that we've figured out phosphorus. Now let's figure out nitrogen. I'm going to tell you that once you've done the phosphorus, the nitrogen tab and the total suspended solids tabs are actually linked. So when we go to total nitrogen, you notice that the 32 is the same. This number has changed, but that's figured from the values tab. That's okay. Infiltration is still there, 100%. It is now 0.62 pounds of nitrogen that you're stopping, and total suspended solids is 20 pounds. So they're different. But I'm going to go back to the phosphorus. Let's change that back to, let's say, 56 again. I want to show you that they're linked. That when you go to nitrogen, stays at 56, and the nitrogen has gone up as well. Just about 1 pound of nitrogen, and total suspended solids has gone up as well. So it's all linked. So it's trying to make this as simple as possible for you. Okay, so there you go. That's a good way of playing with this calculator. Play with it as much as you can. The more you practice, the better off you're going to get at this calculator. The faster it's going to move, the more you understand it, and it'll make life a little bit easier.